It really is just plugging in. What is she? That's just the name of the function and function notation. Because you know we were talking about inputs, outputs, just something a function, vertical like this. So now instead of normally we put y there, but now instead of y, just put f of x or g of x. You're going to do it twice. It's your problem. If it's been 10 minutes, I feel like somebody asked, but you have, oh, Sherry, yeah, she's going first. All right. Oh, she said. All right, here we go. So, our agenda today is to start graphing lines, and we've talked about like is something a function and looking at inputs and outputs, the vertical line test, and then so yeah, our agenda is here. Agenda. Okay. Number 2, evaluate, and we talked yesterday. Evaluate means plug in. So here it says evaluate the function. So it's really just an equation. It's just written a little more fancy with a g instead of a y. So we're gonna plug in x equals 6, and we'll do all the math. And we're also gonna plug in x equals -3. So we're replacing x with these values in the equation. So first I would do 1/3 times 6 minus 2, right? But a lot of you want to know, well, what about that g? What's going on with the g? Well, over here, if I'm taking the x out and I'm putting a number in, I'm going to show what I plugged in right here. So you got to show instead of x that you plugged in 6. After you show it, you ignore it. So you plug it in and then you ignore. The math is here. It's on the right side that you're putting the work in. You're actually going to ignore that. So 1/3 times 6, well, that's 6 divided by 3. So that's 2. 2 minus 2 is 0, so my answer is 0. But if people just say 0, they say, well, what was 0? So I'm going to say, well, G, when the input is 6, gives the output of 0. Inputs and outputs. Did you write it the fancy way I did here at the bottom? Yeah. You did? Oh, okay, I'll do it again. So I'm going to write g of -3 and ignore it. And I'll do 1/3 times -3 minus 2. Ignore that. Okay, 1/3 times -. So 1/3 times -3 is -1. Because it's like having a -3 over 3. So that's -1 minus 2. -3. So when we put -3 in, we get a -3 out. Inputs and outputs. Number 3, I didn't get to yesterday, so number 3 is different. The wording's different. It doesn't say evaluate. So I hate doing 3 because I think it confuses people. Do it. Do you have a question? Okay, so it says find the value of x for which g of x equals -4. So this means you're completely switching the plug-in. So now we're going to actually, instead of replacing x, this means you replace the whole g of x. This is saying that g of x is -4. So here's the function. It's still g of x is 1/3 x minus 2. And this is telling us g of x is -4. So to do this, we're going to take this out. This whole thing is going out. And we're putting -4, not just in the x box. We're putting -4 in. So it's going to look like -4 is 1/3 x minus 2. So instead of plugging in for x, we're plugging in for the result. So I'll pause and let you finish it. Put your line through it. Because the words say find the value of x. Find the value of x when the answer is -4. That's really what it's saying. I'm surprised you're saying negative times a negative, because first thing I have to do is add 2 over. Did you multiply? Did you guys multiply 3 first? No. Okay, so -4 plus 2 is -2. 1/3 x. Now I'm going to multiply by the reciprocal. I'm going to flip this and multiply both sides by 3 over 1. And that gives us that -6 equals x. So going back to the words, it says find x. So we're finding x that time. It's a totally different problem when it's worded that way. You take the g out, you put that in, and then you work it. Alright, so let's look at your assignment, which was on page 219. Alright, so I let you guys just do odds. And number 10. So I'm going to highlight the answers. So for -2 on number 1, you should have got 4. And then when you plugged in 0, you got 6. And when you plugged in 5, you got 11. Wow, I wonder how that fraction went for you guys. show anywhere. You guys gotta show work of putting it in. Who said that? You're really not supposed to leave that. Yeah. Regular schedule now. Okay, here's the answer for 7. Look at all that work. Gosh, got answers. Yeah, that's what the test is. What? Oh, you were trying to figure out which one worked. Well, instead of plugging in. At least you figured it out. Sounds good. Alright guys, we better talk about number 9. It says CFT is the number of customers in a restaurant T hours after 8 a.m. Explain the meaning. So the number inside the parentheses represents the number of hours. So 0 hours after 8, which means maybe right at 8. Or before 8. Maybe we should say before 8, right? There are 0 customers. So this restaurant probably doesn't open before 8 a.m. Or nobody wants to go. So, that being said, can anybody put this into their own words? Yeah? No, somebody's already asked. Do you want to try it now? Let's do it. Do you have your binder? Do you have the pages? But they're just all in that same thing. Yeah, I wouldn't get anything out either if that's how the situation was. I'd never get a page if I had to start through it. Do you have like a folder with crowns? No? Well, let's get that going. That would make this a lot easier. Oh, but you flip like that. I've seen you do that. I think that's nice. Oh, flip it up. Do that in half photo. Come on. You're fine. Like that. Does it stay open or does it flip shut? Alright, this one means the customers, or I should say the amount of customers. You know what word I always mess up is customer and costume. Or what did I write? Costume? Yeah. What's the difference? Is it just the O and the U? Costume and custom? I can't do it. after 3 hours is the same as after 8 hours. So they have the same number of customers at 11 as they do at 4. 11 p.m. and 4 p.m. When you see that, do you see 11 and 4? All I see is 3 and 8. But that's actually 11 o'clock and 4 o'clock. Why is it 11 and 4, not 3 and 8? Thank you. Thank you. You're in it. I didn't think you were. Thank you. In it. This means N hours. There's 29 customers. That one's pretty lame. This means 13.5 hours after 8 is less customers than 12 hours after 8. So around 8 p.m., I guess it starts picking up, but it gets kind of slow. Gosh, at 9:30, that means at 9:30 p.m. there's less than there is at 8 p.m. Because like the T, the number in the parentheses is hours after 8. So we're not starting at 0, we're starting at 8 o'clock. So like this means 3 hours past 8, which is 11 o'clock. Yeah. So 12 hours after 8 is 8 p.m. and then 9 p.m., 9:30 p.m. Okay? Cool, right? All right. I think we've talked about that enough. Does anybody else have another question? Yeah, let's hear it. Yeah, let's look at 10D. Oh, you just want to see the answer? The sum of the percents of U.S. households with internet use in 1997 and 2001 is about the same as the percent of U.S. households with internet use in 2009. It's saying they're equal. You want me to go over it? No. Yeah. Yeah. Yeah, okay, let's look at it. Number 10. These. Alright, so 10 is talking about the number of houses that have internet. And this one is after the year 1980. So what year is this? 1984. In 1984, there were K households with internet. That's weird. All right, let's look at this one. What is 37 years after 1980? In 2017, more houses have the internet than 2010. I can believe that. So when I see 30, I don't really see 30. I'm seeing 30 years after 1980, which is 2010. 2017, more people have internet than in 2010. Yeah, that's right. And this one says that 17 years after plus 21 years after is about the same as 29 years after 1980. This says in 2007, 61% of households have internet. That was right around like maybe a year after you guys were born, 2 years, right? 2007, 61.7% houses have internet. So when your parents were born, almost none had internet. Do you want to go to the bathroom? I love it when the majority of questions I get in math class is only about the bathroom. Who else asked before? Who else asked to go to the bathroom? So are you the last person? Oh, you're going after him or before him? Did you ask before or after? Okay, you and then her. Who else wants to go to the bathroom today? I just don't want to answer this anymore. And then you're gonna go? Who else? Okay, so everybody has the order? Okay. Now we're gonna focus on math. So we're moving on to a new section. 3-5. I got some notes for you. You know, for the agenda, we were graphing horizontal and vertical lines. Yesterday we did a silent reading time. And I let you guys read the book first. If you want to do that again, we can. I kind of switched it, and I'm telling you exactly what you need to know instead of having you read the book. This is in your book, but I shorthand it for you right away. But if the silent reading time is something you guys find helpful, we can do it. So we're graphing all types of lines here. The first type line is the horizontal line. And you can do this right underneath your bow. A horizontal line is like if anybody, you ever been out to the beach and they say, look at the sun on the horizon. Does anybody call this the horizon anymore? I don't know. Like the sun sets on the horizon. Yeah. Look at the beautiful horizon. Yeah. Yeah, people don't talk like that anymore. They may have talked about. Oh, good one. Yeah. Okay. Anyway, a horizontal line is a line left and right. Horizontal lines are y equals equations. It's y equals any number. So, for example, y equals 4, you just go up the y-axis. So you guys know that this is called the x-axis, and this is called the y-axis. A lot of people will graph this wrong because y equals, and people think of the y-axis as going up and down. But a y equals equation is actually a horizontal equation. I know. This is what y equals 4 looks like. And this is counterintuitive to what people will guess. The y-axis is this one. But a y equals equation goes this way. That's crazy. It's like opposite, kind of. People mess that up. Really good, well-intentioned people mess that up. So the reason this is y equals 4 is because everywhere on this line, y is 4. We practiced plotting points before. So this point right here is 1, 4. And this point is 3, 4. And this point is -2, 4. Do you guys see what's happening? On every point, y equals 4. The 4 is negative down here. Every point has y equals 4. You know what students like a lot? I like it too. In fact, I should make a poster. The ordered pairs. We know the quadrant thing. So over here, the ordered pairs are both positive. And then over here, the ordered pairs are negative, positive. Over here, they're both negative. And over here, they're positive, negative. Has anybody ever seen that? Yeah. With regards to x and y? Write that down. I mean, no. If you like it and it helps you, you should. But it's just a little idea. But if you don't have any problem plotting points in the right spot or writing points down, then it's kind of a waste of time to write. But if that's helpful to you, go ahead. All right. Are we ready for the next one? Vertical lines. Vertical lines are x equals equations. So whenever I think about the word vertical, I think about ESPN actually and the vertical jumps and the NFL combine. Anybody? So in sports, they track a lot of times what a vertical jump is like for volleyball, basketball, gymnastics. You got a vertical jump. Look at him jump. Vertical jump. You do a vertical jump?
Isn't that where you hit that thing and it moves?
So vertical lines go up and down just like vertical jumps. So when I graph the equation x equals -2, it's right here. It's an up and down line. But students will make it go this way because the x-axis goes this way. They think x equations go this way. It's actually weird. It's like the opposite. Why would this equation go up and down? Well, if we look at the points, this point is -2, 1. And this point is -2, 3. And this point is -2, -2. And every point on this line has x as -2. So it's a straight line where x equals -2 at every point. Mm-hmm. Yep. Vertical and horizontal, it's either x equals or y equals. It's just a number straight through. Zero slope or no slope, right guys? Alright, are we good? Did you guys get a chance to write down something about vertical line? Yeah, for sure. Some open seats here today. Someone could sit here, front and center. Right in front of Tavis, front and center. You guys over there? I think you have seats over there. No. That's good. Alright, let's move on to this next topic. All other linear functions. Alright, so there's a billion lines out there that aren't straight up and down or straight left and right. All other linear functions have both an x-intercept and a y-intercept. An x-intercept and a y-intercept. So if anything has any kind of slope to it, if it's got a slant at all, it's going to hit the x-axis and the y-axis instead of going straight up and down or straight left and right. So the next thing we're going to do is find x and y intercepts of slanted lines. So straight flat lines, that's just natural. Really, we're trying to actually start working with slanted lines with slope. Let's see a thumbs up if you remember slope from last year.
I know there was one, but I couldn't do it.
Okay, well, every time you learn something again, it makes more sense. So.
And then I got a high score on my math test.
So you felt like you didn't know it, like you did know
No,
it.
because I didn't even know what I was doing. I will keep up on all my questions.
I'm not gonna lie, I did slope for everything.
I did so bad.
To be honest with you, if you can do slope formula rate of change on your EOC, you could probably pass with that one formula. This is slope everywhere. It's just so much talk about slope.
I was guessing and just doing it.
So you're going to building 3 or 8? They're going all over. Alright, here. Alright, so today we're finding x and y intercepts. So to find a y-intercept, you plug in x equals 0. See how they're different? It says y, but I'm plugging in for x. To find an x-intercept, I'm plugging in for y. So it's two different equations. So here's an example. We have this equation. It's 3x plus 4y equals 12. This is a function, a linear function, and we're going to graph it. The way we're going to graph it is finding intercepts. So we're gonna plug in twice. We're gonna do math. We're gonna plug in x equals 0 and do all the math, and then we're gonna plug in y equals 0 and do all the math. This is our last example on your notes, and then we're gonna go to the book. This is it. We just got to get through this problem. Your formula. So we're going to graph a line with a slope, but we're graphing using intercepts. Everybody? So when I take this equation, I'm going to take x out and put 0 in. It's going to look like this. Okay, so if you're not into writing all that and you're ready to do math, do this math. Solve for y. Find y. Okay, just solve an equation. Find y. What is it? Is it Brody? Looks like it's probably 3. We got a 0 here. 4y equals 12. Y equals, well, we would have to divide both sides by 4. And 12 divided by 4 is 3. Y equals 3. Now, when it says graph, you will now plot this point. Plot the point. How did we get 3? We put a 0 in for x. So our point is 0, 3. That's your x and your y. The directions here are actually to create a graph. So we did all of that math so that we could create a graph. I'll do it over here. X is 0, y is 3, and that's called a y-intercept. I'm so glad we're not on a regular old number line anymore. I found that very... The zeros left and right. Well, this is way better.
Can we put this line just to get rid of that number?
Yeah, exactly.
That's the only reason why we do it.
Yeah, we put the 0 in to get rid of it.
Alright.
Alright, so this is called a y-intercept because it's on the y-axis. Now we'll do it again. If you want to plot a line with a slope, you need 2 points. You can't do it with 1 point. You need 2 points. So our second point, same equation. This time we're going to take the y out and put 0 in the y spot. So find your second point, plot it, connect them, and there you have your line graph. So about having 0. You did this
Same graph?
Yep, same target plane. You ready? Kendon, are you ready to do this one? Oh yeah, all new. Light work. 3x equals 12. X equals 4. This time our point is 4, 0. We have x, y. Divide by 3. So our other point, our x-intercept, is here on the x-axis. 4, 0. All you gotta do, you can use your ID. Please make a nice straight line. You can use the edge of your ID. And now we have plotted line. We didn't use slope. We didn't use rise over run. We're working towards that. Instead, we used our x-axis and our y-axis. We did the intercepts. So a lot of times when we cover slope, students forget this. But this is almost a little easier. Because with slopes, you have to think, am I going negative, positive? But now we're just plotting points, connecting them. Yes?
To find your x and y.
Yeah. And then those are always fall on one of the black lines, right? And then you just connect it and there's your graph. For every straight line. So we 2 days ago we talked about linear, nonlinear. This doesn't work for nonlinear. If it's linear, if x is a regular x, yeah, this works for every straight line. Yeah, this it's not perfect, but yeah, it's supposed to be straight. All right, guys. So you have your assignment. I assigned you a good amount, didn't I? What was it? Who wrote it down?
1, 4, 4, 12.
What page was it? Oh, 229. So 1 through 4 are the straight lines. So 1 through 4 are the horizontal and the vertical. It's the 9 through 12 that you gotta plug zeros in. Okay? So we're starting with the plain old lines with no slopes or undefined slopes. And then we're gonna do a nice rectangle of lines. Really sorry. Together. You can do it.
The page on the left. I don't want to go back until you find a page that says, let's go to page 225 and then read it.
Is there a problem you guys want me to start with, or does anybody want a picture? Oh, I already moved the screen. 1 through 4 is the first two that we did. We did a flat and we did a straight up. 1 through 4 is either the horizon or the vertical jump. So you pick. Do you think it goes this way? Use your note. Does it go this way, or does it go this way?
Let me see.
What's your note say about x equals?
To find x.
The x equals no. Use your note. I'll put it back up here. Yep. What she said. Remember the y equals went that way, and the x equals goes this way. I'd love to just draw it up there for you and have you copy it, but I guess that doesn't work. I guess people don't remember that kind of thing. I gotta wait and let you think about it. So I'm gonna send that. Post in school as you didn't post yesterday.